Let's predict the product of the alkene reacting with HBr. I'll redraw it here. When we look at this, we know that hydrobromic acid is a strong acid, and our alkene is a good nucleophile, or a good enough nucleophile, especially when reacting with strong electrophiles or acids like HBr. And it's going to be nucleophilic based on having the pi electrons in the carbon-carbon pi bond. Now, this question was only asking us to predict the product, but we should always think about the mechanism as we're doing that. And so we can show that mechanism where these pi electrons are donated to the proton, while at the same time, this HBr bond, the electrons here, move on to bromide. This is going to give us a carbocation, and it turns out we can add this hydrogen to either of these two carbons because the carbocation we get in both cases would be the same. Let's assume that we've drawn the hydrogen, or we've added the hydrogen to this carbon. At this point, we had also made Br minus. From here, we have this electron-deficient carbocation with an empty p orbital and a negatively charged bromide ion. One of the key rules of organic chemistry is that negatives attack positives, so it's very clear what might happen next in that the negatively charged bromide anion will donate its electrons to that empty p orbital, negatives attacking positives. When we do that, we end up making this new carbon-bromine bond. Our new product, the product of this reaction, is bromocyclohexane.